What's up, Internet? It is I again, that guy again, and today we're going to do some more Kingdom Hearts Final Mix hacking. And what you'll notice, I've actually gone ahead in the table we got. I changed Leon's stat page to second stat page because really it's the second loaded stat page in the current map. And since there's only one right now, it's just Sora, there's nothing in the next one, right? So it'll change depending on the room. If you have Donald and Goofy, right, or party members, it'll be your first party member, then your second party member, and then I think it goes up to like 10 or something total or something like that, but they just keep going and keep going. So if we go and we tell Leon that we want to go fight for our life, skip the cutscene. I think this is no, this just has 2 cutscenes. So you'll see, right? Second stat page, 24, 24, 8 strength, 8 defense. That's one of these guys. It's one of these guys somewhere. And so there's like, what, 4 of them? So there's like 5 loaded stat pages. Oh, fuck. And I wonder if there's an easy way for us to find out. You know what? There is an easy way for us to find out which one we're fucking with, because we can like double its max health or something that doesn't really do much, but makes it oh, it's this one. Okay, that was lucky. So it's this guy right here that we're after, right? This guy we're after. So it makes me wonder, right? Like, he's running around, he's moving, he's rotating, he's jumping, he's attacking. How do he do all of that? Specifically, how do he move? How do they all move? And that's actually done with a piece of like a data structure called an entity, right? It's also how Sora moves, rotates, everything, right? It's also the piece you're locking onto here. So let's say this, let's postulate, right? We wonder, we're curious, how does locking on work? Right now, we're not locked on to anything, right? And this kind of goes back to that whole discussion from last video with pointers, right? Like, what is a pointer, right? It's simply just a reference to another data structure. And the camera, for example, has to follow an entity. And when you lock onto something, it has to know where to move the camera to, right? So they have to have position that they store. And because of that, we can exploit our ability to lock onto things. I think our friend actually despawned. You'll notice second stat page, current and max HP are both 24 now. So I think this is our only guy. But here's what we'll do. So right now, we're locked on to nothing, right? So the pointer for lock on should be 0, or a null pointer, right? So we're gonna pause. On a 64-bit system, i.e. modern computers, pointers are 8 bytes, right? And we actually know it's a 0 right now. So we'll go ahead and scan for 8 bytes that are 0. 5.6 million values, that's amazing, right? So we're gonna lock onto this guy, pause, and we may as well just click not 0. Next scan, not new scan, 3,000 values, right? So now, let's actually just, I see a bunch of stuff changing. Let's just do a few repeat unchanged value. Okay, cool, it doesn't want to do anything more, that's fine. So now here's what we'll do, right? We'll simply unpause, unlock, repause, and we'll exact value 0 again. There we go. So we're down to like 819 possible values, right? We're making a difference in the world here. So now what we'll do, lock on him again, and we'll just say changed value. Next scan. And honestly too, the cool thing is if you can get this to show in hex, which you just right click and then do hexadecimal, you can kind of look around and see, like, all of our addresses here start with 7FF7, right? And so anything we see that starts with 7, you know, same pattern is probably a pointer. And I think I've seen a couple of them here. But this one sticks out because it's the first one. Nothing better than that, it's just the first one, right? We'll right click and we'll say, oh actually, to get it display hex here you have to double click the type and then click hexadecimal. And so we think this is the pointer for the lock on, right? It goes directly to 0 as soon as we unlock. It changes when we lock on to different entities, right? So I might try something, right? Well, let me see. These guys are moving a lot. Let's keep it locked onto this guy. And let's actually do this. Let's copy this value. Let's go to memory view. Click somewhere, Control+G, and then paste the address, right? So now, we got this bit of memory. And it took us off of it because we resized the window. Cheat Engine likes to do that sometimes. Alright, so we're going to actually just unpause And we see a bunch of stuff updating with this guy, right, that we're locked onto. Bunch of stuff. Going crazy. Bro is going insane. So, if we look around, right, this is the first thing I see changing. Interpreted as a float, it's negative 726.57. Interesting, right? So it makes me wonder, this seems to be like a piece. Okay, so let's change it to like, it's like negative 726. Man, I don't know how to do floats in Hex. I need to go ahead and add this to the list as a float, and then we'll change it, because otherwise I'm going to send him to the stratosphere. Alright, cool. So now that we've done that, we're gonna drag this window away so we can see, and we're gonna go and find what we think is one of his axes, right? Let's set it to like minus 500 instead. Let's go crazy. Let's unpause. He moved. He did move. He in fact moved. So now, we know this is positional data, right? We're gonna go back, browse the memory region, and we're actually gonna right click on it, and we're gonna say find what code accesses this value. Well, it doesn't want to show us the thing. That's more than okay. We'll do it again. Come on, show me my thing. I guess. Huh. That's weird. That's okay. There's another way to do it. We'll just right click on it in here. Oops. We'll remember how to use a computer. We'll right click on it here. And there it is. Find out what writes to this address probably, because that's going to write positional data, right? There we go. So we have code ran 16 times, probably every frame, honestly. Let's show the disassembler here, right? And let's try this. Let's say, find out what addresses this instruction accesses, right? So theoretically, everything that has position should be modified by this, we would think, right? Including Sora, including these guys. You'll notice the game decided to go really fucking slow for a minute there. It did not know how to handle it because so many things got called at once. So we're gonna actually, yeah, we're gonna go to a different room. We're gonna go to a room where it's just Sora. Because every frame, for every object, for every frame I should say, this code gets called. And so that's gonna be a lot of times. A lot of times indeed. Come on, bro. What I might actually do, because I know I can set a scene flag here to force Leon fight. Or actually, I think if I set scene 2, it'll just be chill. Where's my scene flags? It's room info. Scene ID. Gonna lock that shit to 2. And we'll see. I don't really know what 2 is here. It might brick it. I think it's the... Oh, okay, yeah, it's chill now. Okay, cool. So, now we will go back to our little bit of code, and we will say, find out what addresses it accesses, right? Holy shit, that's a lot of addresses. There's like 66 and nothing's happening. Let's see if anything changes when we move Sora. A shit ton of stuff changes when we move Sora. So this must be used for way more than just the stuff we're looking for. But what I might do actually now, because it shows us a bunch of info. Shit's just changing so quick. See, that went from like, yeah, there's like 85 values. It's gonna be hard to parse which one is actually in use or not. Okay, that's fine, that's fine. But one thing we do know is we know our lock-on pointer and where that exists. And we can probably use that for something. We're gonna actually lock on pointer. Okay, so now, I mean, theoretically we could lock onto stuff and move where they're at because we know where the distance is from the entity to the positional data, but it's more along the lines, let me try again here. Let's go back to this that we had, right? And we're gonna say find out, let's say find out what accesses instead. Actually, yeah, there's a lot more stuff that accesses the position. Let's find something that doesn't get called too much. Like this doesn't get called too much. Maybe this will affect all of our other things, maybe not, we'll see. Too much, things going crazy, game going slow. See, I'm trying to remember how exactly I got this info that first time. Something we could do. Let's see. Let's do this. Let's go back and do this, because it's obvious it's not writing directly to each individual field, right? That's what these Like it's doing float manipulation, and a lot of times with float manipulation it becomes something where there's a lot of particular processes already tied into it, I guess you'd say. Like let's actually try this instead. Let's hit a breakpoint just like right here. Random breakpoint, right? It's gonna hit, we're gonna step out. Actually, we're gonna toggle and we're gonna step out. Let's see what kind of addresses we have going on here. So I see one, this right here, that looks very similar to where we've been operating at already. D100. And so really, the reason I'll go through it like that, right, is when you're going in a function cave here, when you have a function that you find or like some code that you find and you drop your controller like I did. All right, now it's time to monologue. So when you get stuck like that, right, when you find some kind of like float or something and you find this code that modifies it, and that code also happens to modify like effectively like 80 something different values that seem unrelated, just go up a few levels, right? Go up, step out like 1 or 2 levels, and then try to check the registers and see if you see any kinds of like memory addresses there. Because in the RDI register, right, the destination index where it's writing this stuff to, it's actually got that D100. And if I had to guess, right, let's see. If we look around, see what it's doing with that RDI register, right? Let's actually just step into, keep going with it, RDI plus 10. Okay, interesting. So let's actually do this. This is where it uses RDI, right? And so if we can find how much it increases RDI by, then we will actually know. Here, let's do this. We'll know the size of it, right? And knowing the size of it is very important. Sometimes we need to look up too. Okay, yeah, I'm not seeing anything too crazy. All right, let's step into, and what we're actually going to go and do is we're going to find this RDI plus 10, and we're going to say, find what addresses this instruction accesses instead. And we'll run it. 46, that's still a lot, but I don't know, seems a lot more normal to me. Let's see if we like change it to a float or something. It's probably not a float. Maybe it is. This is definitely getting run pretty often. This is definitely not positional, I think, because this just keeps going down. And these look like valid floats, but that's just because I'm telling it to provide me floats. Let's actually change it to a double, or not a double, an 8 byte hex. Actually, oh, okay. Let's try something here. Let's see something. Because if we go to calculator, right, we're going to go ahead and stop this. We're not getting any new values. It's just making things slow. Go to hex. We'll say DA70 minus D5CO, right? 4BO is the variance, right? What we think is the size of these structures, right? Plus, let's say plus DA70 and see if we get DF20. Boom, DF20, right? So 4BO hex is the size of the entity structure that we're looking at, right? And the way we found that is just kind of fishing around in the code, finding something that seems like it's operating on a pointer a bunch of times, right? Because what we're then doing is every time this code operates, we're going and we're actually checking what value we're operating with, right? And since we're going to operate on all the elements in a row, right, we're going to do the first one, the next one, the next one, the next one in code, right? As part of a loop, it's going to systematically just create you a list of all the memory addresses that have these entities, right? In this case, because the code we chose, it's the, plus 10, so we have to keep that in mind, right? Like if we're wanting to find the first one here, where it starts, I guess, here, I think that's filtered like we want it at 8F70, and we would want to go minus 10 from that, right? So actually, browse this memory region, minus 10, there we go. So this is the start of the first entity. And so let's think about this, right? If the first stat page is Sora, is the first entity Sora? And look, we're seeing all of his values start moving when we move, right? Let's just jump. Okay, so that's the Y. The one that we're seeing move over here, I'm assuming, right? This is probably Z. So here's what we'll do. Here's what we'll do. We're gonna delete this because we don't need it. Delete that one because we, oops, wrong button. Delete that one because we don't need it. We don't really need second stat page anymore, so I'll delete that. We can re-add it later if we want it. It's literally just copy paste. And then, yeah, I want to keep lock on pointer, right? So we're actually going to go in and we're going to see, here, hold up. Got to see where that first one is because that's pretty important for how we're going to structure this. The offset. Okay, so it starts, it's an offset of 10. Because you can tell because this is 60 and that's 70, so 10 hex, right? So what we'll do is we're going to say, I'm going to click this area right here, right click, we're going to add the address to the list, and then I believe this is X position, right? So we're going to say float, so we're at X, actually we'll just say X position, I like that better, and then we know it's plus 10 when we actually get shit together properly, so we'll change that to plus 10, grab the address at the base of the structure, and then right click on X position, add to new group. We're going to say entity, well, Sora entity, because this is going to be Sora's entity that we'll do first. Yes, for address version, and then we'll just paste that bad boy in there. Right click, recalculate new addresses, make sure you set it to 0 unless you want to spend hours fixing everything. Change. Alright, cool. So now, Control C, Control V, change X to Y, shift by 4 bytes, because floats are 4 bytes. Same thing, change Y to Z, just by 4. Here we go. And so now, the other thing we got to figure out is rotation, which is either going to be really fun or really confusing, because it's either that they use Eulers or they use quaternions, and I really hope they use Euler because I do not know quaternions, but let's see. So we know this is about the extent of where things start happening for rotations. What am I seeing here? This float. Pointing. Oh, dude, I think these are quaternions. I think these are normalized quaternions. Okay, so what we're gonna do though, we're still gonna grab our little quaternions because they could be useful to have. I see it almost looks like these are set as doubles instead of... Nah, there's no way they're doubles, bro. There's no way they're doubles, bro. Because they're 0 as doubles. Yeah, it's just got padding. Okay, so we're going to actually go in now, and we're going to say this is plus 20. So let's do this, right? Let's just do this as Z position. We're going to assume it's a quaternion. We're going to say X row. Actually, let's say rotation, because I may as well, right? This is going to be plus 20, I believe. Question mark, maybe, kind of, sort of. Yes, that looks right. That looks amazingly right. Okay, so now we would need to say plus 70. I think that's what, 8 bytes? Yeah, 8 bytes. I don't know if y'all hear that. Someone's dog going crazy in my apartment. Woo. X replaced with Y. And then we're going to go by 8 bytes. Cool. Y'all, I might have just caught a murder on camera or something. I ain't even gonna worry about it, man. It's not my business. Okay, so we're gonna change Y rotation to Z rotation. Adjust by 8. Alright, cool. And so now, theoretically, right, I'm just gonna try something because it's W rotation for the next one, right? W rotation. And so it does look like there are 4 rotation values. Let's just try changing some shit. Let's just see what happens. Oh no, hold up, I want to see what happens live. I'm gonna get rid of that so we can see it, close that so we can see it, close that so we can see it. Alright, let's change this to 0. Huh. I don't think it liked doing that very much. Can we change position? We can very easily change position. Oh fuck, somewhat too easily. Oh no. Cool thing about being out of bounds, Sora jumps like crazy when you're stuck. Alright, so Can we change any of these, I guess, is the... We can. We can, and they'll automatically... Wait a second, wait a second. So I don't even necessarily have to worry as much about... Huh? Maybe I do. I guess the only one you can effectively change is the first one. So wait a second, wait a second, wait a second, wait a second. 60. That's not 60 degrees, 360. Oh wait, that was 260. Hey, we're 360. 180, let's do 180. Oh goodness, I feel like I'm breaking some stuff. But anyway, so now we know. Let's go ahead, right click and group config, hide when deactivated. Now we know how position is stored for entities. And there's probably some other stuff that is related there that we can mess with, right? Like, I don't know. Let's see, maybe the model or something, but that's a little more advanced than where we're at right now. If we want to find the origin of the map, we can. So the origin of this map is right down here. That's some cool stuff we could do. Trying to think. Maybe next video what I'll do is next video I'll show you guys how to actually make a warp cheat, because right now, like as we did earlier, right? If we wanted to go and warp to a different place, let's say we change room info and we want to go to Disney Castle is what we'll say, right? We're gonna lock the warp ID, gonna set the world ID to 2, which is Disney Castle. Boom. Scene ID, depending on what we get, we'll play a cutscene. So let's set it to like 3 or something weird. And then let's just try to walk through a door, right? I don't think this is going to work. You'll see why. See? Weird soft crash. Very weird soft crash. Oh no, hard crash. And so what we're going to dive into next episode is essentially just going through and making a warp code that will allow us to teleport wherever we want without breaking the game, right? But I'll also show you guys a little bit why it doesn't just work like us changing the values and walking through a door too. But anyway, I appreciate y'all's time and I'll see you guys soon, okay? Thanks.